Alright, let's begin. So you should have worked already through 1 through 6. I think I looked that most of the people have been working on it. I will like to note one change. So in this problem, when you're checking for divisibility, let's say that for the first number, so let's say the first number given was 5. The second number the user types in was 2. 2 does not evenly divide into 5. When you inform the user of the results, I want you to actually print out. So print out the number 2 does not divide into 5 evenly. So you need to figure out how the print statement should be done so that you actually change this. So if the user inputted, for example, 3, the output should change so it's printing 3 here. So that it's printing this string with the user inputs. You could also word it differently. You could print out something like 5 divided by 3 is not evenly divisible. Yes. I want it so that whenever I see the output messages, that the output messages actually give repeat the numbers the user gives. So remember, you can print structure. So looking at the print code, so print can take in strings, and it can also take in variables. So if the variables, so if this variable was, for example, 5, then this would print strings with a space and 5. So the output of this command, when separated by a comma, adds in a space in between the arguments or parameters. And then you could, then of course, do comma, divide symbol. And what this would do is add in a space and then the divide symbol like that. And then when you inform the user of the result, I want it to be something along the lines of so let's say that they do something divisible. So 4 and 2. 4 divided by 2 is 2. I only do it differently. I only do 6 and 3. So 3 divides evenly into 6. So either output 3 divides evenly into 6, and then actually output the how many times it does. 2 times. So 3 divides evenly into 6 2 times. Or you could have wrote it instead. 6 divided by 3 is 2. So that's the only modification of this one, is I wanted you to actually output the numbers. I want y'all to get used to actually using the print statement correctly and have it so that it outputs user input. But today we're moving on to spinning designs with loops. You can consider a loop as repeating a set number of times. For example, you want to draw 5 circles, so you can set a loop to create a circle 5 times. So examine the code. Can you guess what it does? So here, it changes the speed to 0. Does pin up, changes the color to salmon, changes the size to 2. Spiral space is a variable. It does it to 0. And then it's going to go to the very center of the screen. Then it's going to turn right 20 degrees. Then it's going to move forward 50 plus 3 times whatever this variable is. And then it's going to put the pen down and then draw a circle with a radius of 10. Then it's going to lift the pen back up. So this is the only time it draws, is between the pen down and pen up. Then it's going to increment the variable spiral space by 1. And its spiral space is evenly divisible by 18. It colors it navy. And if it's evenly divisible by 36, covers salmon. And note that whenever it enters this code, it's going to keep whatever the last value it sent. So if we run this, we can see that what it's doing is spiraling outward. So what it's doing is it's going to the very center. It's then going to move forward by some number. So it's going to move forward. First, it's going to turn right by 20 degrees. So now it's pointing 20 degrees to the right. And it's going to move forward 50 times the first number. Spiral space is 0. So it's going to move forward 50. And then it's going to draw a circle. It's then going to go back. So it's going to go back to the center. It's going to turn another 20 degrees. So now it's at 40 degrees. And now it's going to move 50 plus 1 times 3. So it's going to go to 53. So it moves to 53, draws another circle with a radius of 10. Here it never changes color. The first time it gives its color here, so it starts out with a default color. It's not until we go to 18. So let's see, 1, 2, 3, 4, 5, 6, 7, 8. Or let me start this at 0. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So after doing 18, this is number 17. If we start with 0, 0 is 17, so there's 18 salmon covers. And then on the 18th one, when this is evenly divided by 18, it changes it into navy. And then whenever it evenly changes it to 36, it'll override this and do salmon. So the design spirals outward from the middle, alternating sections of navy and salmon covered dots. So number 9 states modify the program to meet the following criteria. And let me check, do I have on y'all? Oops. Do I actually have guess? Okay. Making sure I actually had you guys do this. So modify every 5th and 10th circle color changes. So instead of doing every 18 and every 36, you're going to do every 5 and 10th the color changes. And I also want you to make the spiral tighter, so circles are closer together and fills the screen without going up. So you notice how this is going off the screen. So what I want you to do is decrease this radius right here, so that these circles come together closer, so that it is stretched inward. So these circles will get closer to the center. This spiral arm will get closer to the center, and so that it pulls it so it fits into the entire screen. So we can have nested while loops. There are times where you want to create more complex algorithms that involve not only repeated steps, but repeated steps inside of repeated steps, but a repetition of repeated steps. So you can place a loop inside of another loop to create powerful algorithms that perform many tasks in a small, concise amount of code. A loop within another loop is called nested loop. or a nested iteration. Iteration is another word for loop. So nested loops take the form of an outer loop and an inner loop inside of it. Remember that Python uses spaces to include all the code inside of a loop. So notice that all this code right here, is all spaced out by 2. So this entire code right here is all under this first while loop. This one is spaced out more. All the code that is spaced out this much is all under this while loop. So for example, the following pseudocode, they construct while j is the outer loop, while I is the inner loop. So this is the inner loop, this is the outer loop. Each time the outer loop j iterates, the loop I runs to completion, iterating as many times as indicated. Again, College Board syntax does this. You can either use this notation, repeat n times, repeat m times, or repeat until, and you give it a condition, repeat until. And remember, most programming languages use brackets, not brackets, curly brackets, to denote all the code that is underneath the loop. Personally, I like that notation because we can clearly see what's all inside the first loop. So everything in this first loop is corresponding to everything between these two curly brackets. Everything in this inner loop is between these two curly brackets, but Python does something different. So analyze the following algorithm and try to predict what the output of the nested loops will be. So while j is less than 10, so it starts with j equals 0, is going to increment. This notation is called the increment operator. It adds 1 to j and then assigns it back to j. So again, this is another way of doing this. You could have alternatively done j equals j plus 1. These two codes are the exact same, but notice this one's more concise. So it's going to first get in here and increment j by 1. So it's going to make j now equal to 1. It started with 0, now it's 1. Then it's going to print. And then I is going to come in here, I equals 0. And it's going to do I less than 5. It's going to increment I again. So I, when it gets here, is 1. So we run this. What we see is when it incremented j to 1. So it's going to print 1 to 5. Then it's going to come over here and reiterate again. Now j is 1. Increments it to 2. And then prints j equals 2. And it does this. Note that this inner loop gets executed a whole bunch, because it's being executed 10 times by the outer while loop, and the inner while loop is executed 5 times. So in total, this print statement gets executed 50 times. So for each iteration of the while loop j, the inner loop will execute 5 times. Since the inner loop iterates 5 times for each iteration of the outer loop, the value of I prints values 1 through 5 a total of 10 times. So observe the while loop example and predict the output in here. So let's look at it. So we create a painter. We give it a shape circle. We call this is new. We hide it. So now we can't see our turtle shape. We set our x position to be negative 200. And while x is less than positive 200, we'll increment x by 500 and set y equal to 200. And we'll go to x comma y. So the very first starting location will be negative 200 plus 50, so negative 50 by 200. And we'll color it red and stamp it down. So how many times will this loop iterate? By just looking at the code. So it's going to go in here, it's going to come in here whenever x is negative 200. This line is going to increase it to by 50, so negative 50. Then negative 100, then negative 50, then 0, then 50, then 150. It will technically look at it at 200, but 200 is not less than 200, so it won't execute that. So it should execute 1, 2, 3, 4, 5, 6, 7 times. And we can see 1, 2, 3, 4, 5, 6, 7 circles. So, recreate A114, Nested Loop 2 in Visual Studio Code, or you can use Trinket. Let's see if at the top. Remember at the top, if you're want to just use Trinket, you can up into this right here, and I'll give you a blank Trinket file. But what it wants you to do is add this to the code and then run the program. So you want to put it in the inner nested loop. So coming over here and putting it in the inner loop. We run it. You can see that after it makes a red one, it's going to come over here and decrease the y value by 50 and go down, creating blue ones. So here the y value starts at 200. While 200 is still great, so I'm greater than 0. We're going to shrink it down by 50, so the next value being 150, then 100, then 50, and then 0. But 0 doesn't execute, so we don't have 0 being ran, so it's going to do it 4 times. These are the values that get popped in. So for the assignment, what you need to be doing is trying to create this. You'll notice something different. This one has the first row red. This one has the first column purple. So we're going to need to somehow modify this code so that instead of doing it by rows first, you're going to do it by columns. So modify the algorithm so that the nested loop stamps the turtle using new colors in a left to right pattern. So here we're outputting the first X, and then we're coming over and doing Y's downward. So we're doing this by where the innermost loop is modifying the Y's. So what it's really trying to want you to do is to change the logic so that we output a Y first, and then the inner loop is going to manipulate the X's. So you use like purple and yellow or purple and gold. You can also use speed 0 to start to change the speed at which it draws. So let's see how quick this actually was. So if I come over here and add speeder, yeah, it significantly increased how fast it was. I do not know. So Python turtle default speed. is an integer value that ranges between 0 and 10. So coming over here, normal is 6, 0 is fastest. 1 is slowest. So the speed values really go from 1 to 10. But they set 0 means no animation takes place. So what 0 means is execute as fast as possible. Whereas numbers 1 through 10 actually cause it to pause and do some animation. Whereas 0 means do it as fast as possible. So the speed really goes from 1 to 10. Whereas 0 is unique in meaning that it's going to execute it as fast as the computer can. Again, if you have a question like that, look at the official documentation by Googling your answer, or quick Googling your question. Because there's going to be a lot of times where you do not know that and you figure it out. It's always important to be able to figure things out like that. So, let's look at another set of nested loops. Predict and sketch what this algorithm does. So, we're just going to start out at -200 and 0. You also create a move x and a move y. So we're going to modify our x and our y by this increment. So let's go do this 100 times. Because y begins at 0, it's going to increment y by 1. And then after it's done, it's going -1, so that move y is 0. So now the y doesn't change. Oh no, it's not. It's going to change it to -1. So right here, it's going to start at -200, 0, and it's going to continually add 1 to them, moving. So it's going to do x and y, so it's going to be going up to the right. So it should be moving up and to the right in this direction. And then right here, we're going to go reverse the direction and make it go back down to the left. So what we should see happening is it go up to the right. And then since we only changed y value, it's going to come back down. But move x is still increasing. So it should print it and make it go upward. Then by 100 pixels. So it's gone up. It goes up by 1, over by 1, up by 1, over by 1. Or technically it does the upper by 1 first. So it goes to the right by 1, up by 1, over by 1, up by 1. Until it gets to 100. Once it gets to 100, the y value, the amount it's moving changes. So now it's going to be going over by 1. So still move x is 1, so it's going to go over by 1. And now that y is -1, it's going to go down by 1. So over by 1, down by 1, over by 1, down by 1. What you're supposed to be doing in this program is recreate it. Run the code to compare the results. So recreate this in Visual Studio. Again, you don't have to do it in Visual Studio, but I recommend it. Modify the program in the outer loop so that the program has 2 peaks. So what you want to do is go up. You want to go upper by 100, up by 100, while drawing a line. And doing it 1 pixel at a time. Go back down, then go back up, then go back down. So once you do that, here I want you to then, at the very right side, make it come back and go back down, then back up, back down, back up. And finally, put it all in an infinite loop so that your turtle runs forever. So on 19, what your final code should look like is it's going to start right here. It's going to go up like this. It's going to hit this point, go down, hit this point, go up, hit that point, go down, hit this point, go here, 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 and then it's going to repeat forever. It's just going to keep making this infinity symbol. It's just going to run forever and ever and ever and not stop going back and forth like this. Makes sense? And then here, below is an example of expressing an algorithm using iteration without using programming language. This is known as a flowchart. Flowchart. So in a flowchart, rectangles represent statements. They're actions. So here, so this is this executes whatever's in the rectangle. So first we set line equals 0. Follow the arrow. We put a pen down. Then we follow the arrow again. There's only one arrow coming out of it, a rectangle. Then we're going to draw a circle with radius 5. We're going to lift the pen up. We're going to move forward by 20. We're going to increment line by 1. Then we're going to get to this diamond shape or rhombus. These diamonds are called decision statements. It asks a question. Is line less than 5? If it is, we follow this arrow. If it's not, we go here. Usually, though, in flowcharts, the last statement to be executed uses an oval. It's not important, but usually you put end or stop program with an oval. But if it's less than 5, we'll come back up. Using a flowchart can sometimes help you program and do something, figure out your algorithm before actually doing code. So what does this statement do? What does this flowchart mean? So we start with line equals 0, we come do a circle, move over by 20, then come back and increment line and keep doing this until line is equal to 5 or greater. So this should output 5 circles, evenly spaced. So the this represents the program you modified earlier to avoid 0 iteration condition and draw 5 circles. So another thing I want y'all to do is draw a flowchart. It can be of any algorithm of your choice as long as it uses iterations. And you should be using squares and diamonds. Are there any questions about 114? I believe the only thing in addition was these 2 programs. By the way, I'm going to stop helping y'all by writing the solution down here. You notice I've been kind of doing y'all's homework for y'all. If you paid ultra close attention, I would actually solve your program by writing up here, and if you went back and pieced it together. Now you're going to have to start figuring it out more by yourself. So here, again, you want it to come out here and go in an infinite loop. If you have any questions, you can ask. Again, if you copy and paste your code and then comment on it, so you can, some people have already done it. So whenever you, so what you can do if you need help, copy whatever code you have already to the Google Documents and put a question, private comment on that homework submission. I can come in and look at your code and comment what's going on and help. But I believe that's it. As I suggested, you might have wanted to look ahead. You looked ahead and did. You work out for like 4 days. You have power at your dad's house? By the way, the code word of the day is derivative. Code word of the day is derivative. They probably counted everyone present. Yeah, I did it to everyone. But that's it for the day. So finish these two programs. Finish any of the comments. Like which one are you talking about? Yeah, in the video I did went over 1 through 6. Oh no, today I began after Wednesday's video. So Wednesday we didn't have class physically. We had it remotely. So everything 1 through 6 was in the video. Well, I post the video to everyone, so y'all can, when y'all go home, can actually look at the video again. Alright, that's it for today. I'm stopping the video. Y'all have any questions before I actually stop it? Alright. Well, that's it for today.